Sorry about that. I thought I was running out of time on the video. Okay, so now we need to graph this. We've got all the key points identified and key lines, the asymptotes. So what we've got to do is figure out what happens as we get close to positive infinity. We know that our function is going to get close to this asymptote because it's a horizontal one. So it's either going to be right above or right below the asymptote as you go towards positive infinity. Well, the way we figured this out is that we've got to look at what our sign chart said. It's positive. So I've got to be on the positive side for y. Positive y's are above the x-axis, so it's up over here. Now as we come in close, I can't cross a y-axis, a vertical asymptote. I cannot cross the x-axis because there's no x-intercept. So this must curve and go upwards here. Likewise, as we go towards negative infinity with x, my asymptote is what I get close to. So my function is either right above or right below. We look at our sign chart, which tells us it's negative. That means we're right below the asymptote. I come in close to the vertical asymptote, and it must go downwards. It either goes up or down when you hit a vertical asymptote or get close to it. It has to go down in this case, because again, there is no x-intercept right around here. The only x-intercept was over here at 1, 0. So I can't curve and go up because I would have to cross the x-axis. Instead, I will curve and have to go downwards. So I've got my two end pieces of this function. That takes care of the horizontal asymptote part. Now I've got to figure out what goes on here between -2 and +2. Well, our sign chart tells us between -2 and +1, it's positive. So that means I've got to be up here somewhere. So it starts out close to the vertical asymptote. It's got to come down, go through our y-axis intercept. When we get to the x value of 1, that is an intercept. So I either touch or cross. The sign after 1, but before 2, is negative. So that means I must have crossed to get y values that are now negative. And as the x's get closer to the vertical asymptote, I've got to curve downwards. And again, I'm curving downwards because there's no more x-intercepts for me to cross to go back up. I hope that makes sense. But this is really trying to figure it out. If you want to check it, certainly put it in the calculator with lots of parentheses, and this is what it looks like. Very close to what we graphed. We just want a rough sketch, so that's perfect. On the homework, you absolutely have to go through all the steps. If you just give us a graph looking like this, that means you probably just took it from a calculator or a graphing program. So make sure you're doing the work yourself. Okay, example 2. Same steps here. First thing I need to do is factor the numerator, so x plus 1 times x minus 1 over x. I need to find my x-intercepts, and we said on the previous one, it's really the numerator that gives us the x-intercepts, so I am going to set 0 equal to the numerator. Oops, that should be a minus there. And solve, set each factor equal to 0 and solve. So I've got x plus 1 equals 0, x minus 1 equals 0. So I have an x-intercept at -1 and at +1. Okay. Y-intercepts. Y-intercepts, we set x equal to 0 and plug it in. So we've got y equals 0 squared minus 1 over 0. Remember, we cannot divide by 0. That gives you something undefined. That means there is no y-intercept. Vertical asymptotes. We find our vertical asymptotes by setting the factors in the denominator equal to 0. So x equals 0. Well, there's nothing left to do. It's already solved for x. So my vertical asymptote, the single vertical asymptote, is at x equals 0. Horizontal asymptote or oblique asymptote. Again, we've got to look at our degrees to figure this out. I have a larger degree on the top than the bottom, so that tells me it's going to be oblique. So let's cross out the horizontal asymptote. The way we get the equation of the oblique asymptote is to divide the numerator by the denominator. And I'm looking for the quotient. So we're going to take x and divide this into x squared plus 0x as my placeholder minus 1. So x times what is x squared? That would be x. X times x is x squared, and I need to subtract. That gives me nothing, so I bring down the 0x. X times what gives you 0x? Well, that'd be 0. And all I care about is this piece. I don't need to finish this off, because if I multiply this, I get 0x, which is 0. Bring down negative 1. X does not go into negative 1. This helps give me the equation of the oblique. It's going to be y equals whatever is in the numerator, or whatever is in the quotient. Do I have to write the plus 0? No, not at all. But this will help me when I graph it to remember that that's the y-intercept with the slope of 1. Okay, let's create our sign chart. And again, on the sign chart, we put our x-intercept. So we've got a negative 1. We've got a positive 1. We also put our vertical asymptote, which is at 0. And that's all we put on here. And now we've got to figure out the sign. So on the interval between negative infinity and negative 1, what sign will all these x values give us for y? So I'm going to plug in probably a negative 2. And I'm just plugging it into the function. I can plug it into the unfactored or factored form. It doesn't matter. I think it's probably easier to put it in the unfactored. So r of negative 2 equals negative 2 squared. And again, notice the negative 2 has parentheses, minus 1 over negative 2. Negative 2 squared gives you positive 4, minus 1 is 3 over negative 2. Positive divided by negative is just a negative. So again, what I'm interested there is the sign. And we'll do the same thing here between negative 1 and 0. Why don't we try negative 0.5? So I've already plugged this in, and we get a positive 1.5 is your answer. So it's a positive sign. We've got to plug, I keep doing that, plug something in between 0 and 1, and let's just put positive 0.5. We actually get out a negative 1.5 when you plug that in, so that's a negative. And then we need something greater than 1. And again, you can pick any number greater than 1. I'm going to just pick the number 2. That's nice and easy to enter. So if I plug the 2 into this equation, I will get out, let's see, what was that? 3 halves. So that's positive. So my signs are going to be negative, positive, negative, positive. And we now need to graph it. So let's go ahead and draw in our asymptotes first, positive and negative 1. And negative. Okay, we've got those. Oh, those should have been x-intercepts. Ugh. Okay, sorry about that. Let's see if I have another one I can draw on. I do. Okay, I will draw it right here. And this is what happens. Those are x-intercepts. My actual vertical asymptote was at x equals 0. So let's put it right here so you can see both of these. And I now need to put in, I've got my x-intercepts, I've got my vertical asymptote. I need to graph my oblique asymptote, which was at y equals x. Y equals x is a diagonal line, and it's a positive slope, so it's going to come from the bottom left corner, again as a dotted line, going through 0, 0 to the top right. I'm trying to be as accurate as you can. Now let's graph this. So between negative infinity and negative 1, we are negative. And I know that I've got to get close to this asymptote the farther out I get. So it's got to be fairly close to here. And I've got to decide which side of it, this oblique asymptote we're on. If we were below it, I can't get up to my x-intercept. So I've got to be up here. From negative 1 to 0, I'm positive, so I've got to come up like this. On my second side, between 0 and 1, I'm negative, and I then become positive according to my sign chart. So this is what it looks like. And again, it's based on the sign chart and where the x-intercepts are and your asymptotes. Okay, we'll do one more example.